So today we're going to be doing lesson 6, ratio tables and their properties. And the first thing we want to know is just what is a ratio table. So a ratio table is just a table in which we put ratios that are all equivalent. It's a way for us to look at them, examine them, and maybe even see some patterns that they have. So here I've got an example where I'm looking at the ratio of books I have to DVDs. And so it says that I have 3 books for every 2 DVDs. So I'm just, instead of drawing a picture, I'm just going to write, let's see here, this way. I'm just going to use the capital B for books. And I'll use D for DVDs. And so this is going to show that my relationship of 3 to 2. So for every 3 books, I have 2 DVDs. Now, I want to just continue to make other equivalent ratios. So if my relationship is 3 to 2, then I also know that if I add another set of 3 and another set of 2, then another equivalent ratio is going to be 6 to 4. I could do it again. And I could I could get 9 to 6, and maybe one more. And then I would have 12 to 8. So that's basically what a ratio table is. I guess I could finish this up here with, we know that the next ratio that I would have would be 15 to 10. So that's all a ratio table it is. It's just a table which displays equivalent ratios. And even though these are in order now, they don't always have to be in exact order. The only thing that we have to make sure that's true about them is they have to have equivalent ratios. So let's look at, if I can get this thing keeps glitching, I apologize. Let's look at some of the relationships that we can see in a ratio table. So the first thing that we're going to look at, I suppose we should fill out this ratio table. And I need to notice that it's not in simplest form. And we always want to make sure that it is in simplest form if possible. So we've got a 2 to 4 ratio, which I know will simplify to 1 to 2, which means that any ratio that I put in this table has to be equivalent to 1 to 2. So let's just make some. 3 to 6 would be 1, 4 to 8 would be 1, 9 to 18 would work. And then let's do something more fun. Let's say like 50 to 100. That would work. Okay, so now let's look at some relationships that we can see within this ratio table. So the first thing that I want to look at is this relationship within each individual ratio. So let's look at just this first ratio here, 2 to 4. And I want to look at what's the relationship between the number of kids I have and pens? Well, it's doubled, so it's times 2. There are twice as many pens as I have kids, so it's times 2. Same thing here. What's the relationship between the kids and the pens that I have here? 3 and 6. Well, it's 3 times 2 is going to give you 6. 4 times 2 is going to give you 8. 9 times 2 is going to give you 18. And 15 times 2 is going to give you, 50 times 2 is going to give you 100. So there's this constant relationship, within each individual ratio, going from one to the other. And this is always going to be true, and it'll always be constant if the ratios are equivalent. The second relationship I want to look at is the relationship between different ratios. So for instance, notice that if I double the number of kids I have, so I'm going to go from 2 to 4, so times 2, I'm going to double it. If I double the number of kids I have, well, then I would also have to double the number of pens that I have. Or if I tripled it, let's look at this one. Let's look at 3 to 6. if I tripled it, I would get 9. So 3 times 3 is going to give you 9. And the same thing would happen here. 6 times 3 is 18. So it's like a mirrored relationship. Whatever happens to the kid side has to happen to the pen side. And this becomes really useful when you're trying to find more equivalent ratios. Let's go back. Let's look at this one. What about if I go from 2 to 50? What's that relationship? Well, how do you get from 2 to 50? You would multiply it by 25. Well, then it better be the same over here. How do I get from 4 to 100? It's exactly what I would do. 4 times 25 is going to be 100. So that's those are the two different relationships that you can see. There's the inner ratio relationship, and then there is the relationship between different ratios. And these will always be present as long as you're looking at equivalent ratios within a table. Okay, so let's go to a quick example, and then we'll be done with this video. Where did I put my example? So here is a ratio table. This is something that you might have to do in your work, where I want to fill out this ratio table, fill in the blank spots. So they've given me certain numbers, and I have to figure out what is going to go there. Now, notice that they've given you this ratio here. And the thing that's hard about it is it's hard to kind of grasp what is the relationship of 15 to 18. And the reason why that is because it's not simplified. So anytime you can, you always want to simplify. So I'm actually going to just write a little box out here, and I'm going to simplify this ratio. So I'm going to simplify this. Let's see here, 15 to 18 will simplify to 5 to 6. Oh, look there. I've got a 6 here, and I just simplified my ratio here, and so I know that this is going to be a 5 because they have to be equivalent. Okay, so from here now you can really play. There's two different ways we can get to 36. I could either take 18 and double it, or I could take 6 and multiply it times 6. But for right now, let's just start with 18 and double it. So 18 times 2 gave me 36. So 15 times 2 will give me whatever answer this is. And this is going to be 30. Now I want to solve for 72. What number will go with 72? I could just double 36 again, but I want to show you that you can do it with any number within your ratio table. So I'm going to look at 6. I know that 6 times 12 will give you 72. So I know that the answer that's going to go in this box is going to be 5 times 12, which would be 60. So that's the basic idea with the ratio tables and how to solve them. Go ahead and do any extra practice that you want to do at the bottom. Let me know if you have any questions. Ratios or